Okay, let's just dive right into this. If you work in IT support or software engineering, you already know the familiar creeping dread of a vague user complaint. You know the one. It drops into your queue with absolutely zero context and you're just left to play detective. Well, welcome to this explainer. Today, we're literally looking right over the shoulder at Sentry performance monitoring, and specifically how it gives IT support engineers the exact tools they need to stop guessing. If you want to follow along with us, you can actually pop open a free demo environment right now at sentry.io/demo. Let's look at how to finally diagnose those incredibly frustrating slow support tickets.
We've all seen this ticket. Hey, the checkout button is just spinning. Fix, please. Right? This classic, completely unhelpful user complaint is the real antagonist of our case study today. The enemy here is ambiguity. Users aren't going to hand you network logs or a beautiful stack trace. They just know the app is broken or unbearably slow. And let's be real, when it comes to performance, slow is basically the new down. These issues are notoriously tough to reproduce locally because your test environment just doesn't have production-level traffic or data volume.
Here is our quick roadmap for today. First, we'll talk about the hardest support tickets, then navigate performance metrics, read the waterfall trace, isolate bottleneck spans, and finally, actually fix that slow checkout.
All right, Section 1, the hardest support tickets. Moving right along to Section 2, navigating performance metrics.
So to actually diagnose a slow application, we really have to wrap our heads around percentiles. Traditional crashes, they're relatively easy to spot. They throw a big unhandled exception, a server errors out, you get a neat little stack trace. Easy. But performance issues are silent killers. To put that into perspective, data from a Digital Enterprise Journal study shows organizations lose an average of over $600,000 a month, a month, just due to application performance slowdowns. Lost revenue absolutely hides in slow code. So to quantify what slow actually means, Sentry tracks performance using metrics like P50, P75, and P95. You absolutely cannot just rely on averages, because in distributed software, averages lie to you. The P50, or the median, that just shows what the middle-of-the-pack user is experiencing. If you only look at the median, you might see a perfectly healthy 200 millisecond response time, think everything is totally fine, and entirely miss the real pain hiding in those higher percentiles.
So why does this distinction actually matter? Well, it all comes down to that top 5%. If you're looking at your P95 latency metric and it's showing a 7-second load time, that means 5% of your users are having an absolutely terrible experience. In our e-commerce checkout scenario, a 7-second wait translates directly to abandoned carts, deeply frustrated customers, and lost sales. That 5% represents your most critical, revenue-impacting support tickets. And think about it. When performance degrades, the users taking the hit are usually your power users. They're the ones with the largest carts, the most data, the most complex queries. Fixing their experience is absolutely crucial.
Okay, Section 3, reading the waterfall trace.
So we've got our broad dashboard metrics. But how do we actually get from a high-level P95 number down to an individual user's spinning checkout button? We need to shift focus down to a single, slow transaction using distributed tracing. This acts like a chronological timeline, linking a front-end user action straight to back-end execution. So at 0 milliseconds, the user clicks checkout. At 150 milliseconds, the API request triggers. At 350 milliseconds, the database query begins execution, and it just sits there and sits there. It doesn't actually complete until 3,350 milliseconds. This visual waterfall shows you exactly where the time just evaporated. Instead of guessing if it's a network glitch, a slow API, or some front-end rendering issue, you have concrete proof of the exact holdup.
Now, in distributed tracing, operations are tracked as spans. Think of a span as the smallest unit of work. And these spans are assembled into a complete trace journey. Modern web apps are incredibly complex. It's like a giant puzzle. A single click might travel from a mobile browser to an API gateway, bounce through 3 different microservices, and finally hit a database. Tracking that exact path is nearly impossible with traditional server logs. But this end-to-end trace visibility, that is exactly what takes us from a vague, "it's spinning" complaint to finding the precise line of failing execution across a huge, multi-layered architecture. Which brings us to Section 4, isolating bottleneck spans.
All right, now that we can see the trace, we need to isolate the specific villain within that waterfall. In complex web apps, that villain is very frequently a bad database call. The cool thing is, Sentry has automatic detectors to find these bottlenecks for you using some very exact criteria.
First, the span operation has to start with DB. Second, it has to specifically be a select query. Third, the duration has to be greater than 500 milliseconds. And crucially, it must be detected consistently. We're talking at least 100 times in a 24-hour period. In modern web dev, a 500 millisecond database query is literally an eternity. And that consistency requirement, that is absolutely vital. By demanding the issue happens 100 times in a day, it ensures you're chasing a persistent, systemic database bottleneck that is fundamentally ruining the user experience, rather than wasting your engineering hours chasing a random, one-off network blip.
Oh, and here is another incredibly common bottleneck you'll definitely run into in the Trace Explorer, the infamous N+1 query problem. This happens when your code runs one initial query to fetch a list of items, and then, usually buried inside a loop, fires off dozens of sequential additional queries for each individual item. Object Relational Mappers, or ORMs, make this extremely easy for developers to do entirely by accident. I mean, it looks super clean in the code, and it tests completely fine locally with just 5 items. But in production, with 50 items in a customer's cart, boom, that single checkout request quietly turns into 150-plus round trips to your database. So instead of one long bar in your trace, you see this massive staircase of 100 tiny rapid-fire spans, creating massive aggregate latency.
And finally, Section 5, fixing checkout is slow.
Let's bring the whole shebang together. We're going to apply these concepts to our original, super vague support ticket, and imagine we're stepping into that demo environment to fix it. The workflow is incredibly fast. Step 1, open the performance dashboard. Step 2, filter by your P95 checkout latency. That immediately surfaces the users experiencing the absolute worst delays. Step 3, click right into one of those sample slow transactions to view the distributed trace. And step 4, look at the waterfall and identify that bottleneck span.
Instantly, the duration impact is completely revealed. Check this out. Out of the entire 3.5-second checkout transaction, one single database query took 3.0 seconds. Sentry visually proves that this one span is eating up the vast majority of the time. This is a real game changer because it tells your engineering team exactly where to spend their effort. You don't need to rewrite the front-end rendering logic. You don't need to tweak the API gateway. You literally just need to index that specific database table. You've instantly gone from a user whining it's spinning to knowing the exact SQL query causing the holdup.
The before and after here is just staggering. Think about it. Before tools like this, you were totally guessing. From server logs, begging users for their browser versions, attempting these manual reproductions in completely sterile test environments, and honestly just wasting hours of valuable time. But after incorporating performance monitoring and distributed tracing, you are pinpointing a 3-second database query span in just a few clicks. Your mean time to resolution drops dramatically because your IT support team now has true surgical precision.
So I want to leave you with this provocative thought. What hidden database bottleneck is secretly ruining the checkout experience for your most important users right now? Seriously, if you aren't looking at your trace waterfalls, you simply don't know. I highly recommend heading over to sentry.io/demo to practice finding these bottlenecks for yourself. Thank you so much for joining me for this explainer, and happy hunting.